Hi everyone, I'm Kat and I'm here with my colleague Erin. We're both here from the People Analytics team at Wayfair. We're very excited to be here today and talk a little bit about topic modeling and some ways we've applied this at Wayfair. But before we jump into our content for today, I'd love to share a story with you. So like many early 2000s kids, I grew up watching Ice-T on SVU, wanting to be a detective, wondering what makes people act the way that they do. Like, why do my sisters get so upset when I'm following them around or listening to their phone calls, especially if they have nothing to hide? But years later, and many conversations with my mother about boundaries and that my sisters weren't perpetrators, I found the wonderful world of people analytics. I still had some of the same questions. What makes people act the way that they do? But my questions also started to evolve into what makes people happy at work and what keeps them at a company. That is exactly what our people analytics team aims to do at Wayfair. We aim to study the employee experience from the moment that they walk in the door to different experiences throughout their tenure and different areas where we can drive change. Within that data, there's lots of quantitative information and also lots of qualitative information. And that qualitative information is very, very important to our team. First and foremost, it gives employees a voice and a way to express themselves in a way that's comfortable to them. We're also able to identify unique and unanticipated trends within the data, clarify sentiment on different complex issues going on in the organization, explore new areas, and what we can do with that data and the information that we gather is really infinite. However, up until recently, we didn't have a way to scalably do this. So again, we're very excited to be here with you all today and discuss how to use topic modeling and then talk through 2 applications where we used it at Wayfair. I'll hand it over to Erin to kick off our demo.
Thank you, Kat. As Kat mentioned, we're about to walk through the technical part of the presentation. And this is going to be a little bit different from a lot of the presentations I've seen this morning. But I want to ensure you that even though we're going to go through this in pretty rigorous detail, I want 2 things to happen, and there to be 2 main takeaways. First is that topic modeling is easily attainable and achievable for every team and company represented in this room. And the second is that it can immediately be applied to improve the employee experience and ultimately drive value for your company. And the reason that I'm confident in this is because Kat just mentioned that text data is valuable and rich. And it gives you honesty and a level of detail that you can't really get in any other sort of way. But it's incredibly difficult to process at scale. Like, I can't read 4,000 performance reviews and understand the trends and be able to cut it by different departments and levels on my own. But what topic modeling allows you to do is summarize vast quantities of text. And just by creating a simple model and performing some simple data manipulation, you can take vast quantities of open text and transform it into a numeric data set that any analyst at any company represented in this room can use to drive insights, to drive value for the business. Now, how does this work? Well, what topic modeling is a statistical model that allows you to find latent themes or topics that exist within a collection of documents. And we're going to talk about topic modeling, but for the majority of this presentation, we're going to be talking about LDA, more specifically, which is the most common type of topic modeling algorithm. And the reason it's common is because it's incredibly well documented, which means you can actually go in, see what's possible with your model, and you'll understand what inputs are necessary to make it go. And it's a probabilistic model, which means it ignores word meaning and it looks strictly at probabilities. If word A appears, what is the likelihood that word B will follow? And because of this, the topics that are created typically follow 2 patterns. One is that words that appear near each other should be grouped together. And the second is that words that are used interchangeably should be grouped together. So in these 4 sentences, talking about somebody's improvement and their ability to manage their direct reports, Direct reports is going to be grouped together as they're paired. And managing, mentoring, and teaching will also be grouped together because they're used interchangeably. So if we were to process these 4 sentences and try to summarize them and create a topic for them, it'll say, this is the teaching direct reports topic, talking about improvement and development and their ability to manage their direct reports. Now I want to talk about how do you actually make this go? You only need 4 things to make a topic model. One is a corpus, which is just a fancy word for the text that you want to look at. And it does need to be in a specific format, where every document or piece of text is a list of individual words. But actually on the next slide, I'm going to walk through how do you take that raw text, that raw performance review, that raw comment from an engagement survey, and get it into this format. The second thing you need is a dictionary, which is just a list of all the words we're using. The third thing we need is a vector representation of the corpus. And what this vector is just the thing the computer uses to do the math. And this output at the bottom, each word is represented as a numbered pair, where the first number is what number word you are in the dictionary, and the second word is how many times that's been used so far in that document. So if our first sentence was, I like big dogs more than small dogs, first I would disagree. I have a 28-pound dog at home that I just love so much. And the second thing, moving on from my dog, which will get me distracted. Each of the first 7 words will be unique. So I like big dogs more than small will be 0 through 6. And then when dogs is used again, it will refer back to that original placement. And similarly, when we're looking at our second number, each of these words was used once until dogs was used a second time, and it will denote that. And the fourth thing that you need is the number of topics for the algorithm to create, which Kat is going to walk us through later. But before we go there, I do want to talk about cleaning your data, because this is incredibly important. Any analyst knows that before you start building, you need to check your data and clean it and get it into a format so that the model can build something accurate. And this is incredibly important in text data, because there's so much stuff in text that you just don't need. Whether it's symbols, numbers, punctuation, words that just have no meaning. We need to pare all of that away and get down to the inputs that we need for analysis. So the first thing that you're going to do is get rid of the punctuation, get rid of those numbers, and get rid of the capital letters. Because the computer will make a distinction between a word that's capitalized and one that isn't. The second thing you're going to do is tokenize, which just means split up the sentence into individual words. And you're going to remove stop words. Stop words are a pre-agreed upon list in the data science community that these words just don't matter. That's the, and, all of our prepositions. Next thing we're going to do is create 2-word phrases. So some words are often paired together, and by using GenSim's phraser module, which is just 2 simple lines of code, it will pair those words together, like text analytics. And the last thing that we want to do is stem our words. And for me, I think this is the most important thing to do. If anybody in here took Spanish like I did in high school, you all know that there are so many different ways that you can say the same word. And I remember that I used to learn how to conjugate verbs 6 different ways in the present tense alone. And what stemming does is it allows you to transcend that problem, transcend part of speech, transcend word endings, and get down to the root that is really important for analysis. And once you've went through this 5 steps, you have your documents in the way that they need to be for this model to run. Then with 1 line of code, you can create your dictionary. With another line of code, you have your vectors. And then you finally have one last problem to solve, which is how many topics should you create? And now I'm going to have Kat walk you through how to do that.
Thanks, Aaron. As Aaron mentioned earlier, there's 4 key inputs when you're topic modeling, with the 4th being how to select the optimal number of topics for the algorithm to create, or in other words, model fit. Tying this back to his earlier example, when you're looking at the optimal number of topics or model fit, What you'll really find out is if these words are statistically significant, or if they're practically significant too. So it will indicate to you if words like improved, managing, and development are truly related, or if that's just due to chance. Before jumping into the different procedures that you'll take as you're assessing the model fit, you'll want to have sufficient business context so that you're making theory-driven decisions and that you know already that this relationship isn't just due to chance. One way of testing the efficacy of your model is to look at coherence values. All you need to do to look at these coherence values, and in this step of model fit, is to create a loop that builds a model for every possible number of topics, and it applies a coherence value to each of those number of topics. And then within your code, you'll also create a graph. As you can see up here, we have up to 50 different numbers of topics with coherence values associated to each one of those numbers of topics. To select the best fitting model, you'll look for the highest points on the graph and where the data starts to level off a bit. So as you can see, there's 3 points within this graph that we'll want to test. This is an iterative process, so you'll continue to look at coherence values and also go into our next step, which is looking at topic distribution. You'll go back and forth between these two steps until you find the ideal fit. While coherence values is more of a statistical test, topic distribution is more of a judgment and gives you that indication on if your model is practically significant and meaningful. So with topic distribution, you look at the frequency of topics within your model to see if the pairing of words and the grouping of words within your topics makes sense. For example, when we ran this at Wayfair, we started out with a topic model that just had one topic, and that topic was Wayfair. Well, that's not wrong. All the topics were on Wayfair. We wanted to gather more insights than just a one-topic model of Wayfair. So we removed that word and continued to test and iterate until we found a topic distribution and model that had both high coherence values and made sense. After you select your model and you build your model, you can run any piece of text through this model and it will associate a topic with those sentences. For example, she's also taken it upon herself to have challenging conversations around age discrimination with multiple hiring teams, is most associated with handling tough conversations. Now I'd like to walk you through an example of how we'd applied this at scale and some examples of how we've used this at Wayfair. So as mentioned previously, our team works with a number of different data sources spanning the employee experience. We saw an opportunity to use topic modeling within our engagement surveys because our engagement surveys, every time we send them out, gather around 10,000 open text comments. And in our tiny but mighty team of 2, it's not really feasible to sort through all that data on our own. So we started out with 10,000 comments, which translated into thousands more sentences and hundreds of thousands of words. We were able to create topics based on these sentences and run each sentence that we received on the survey through that model. And then we were able to associate topics to each of the 9 different departments at Wayfair. Then with a simple pivot, we were able to identify the most commonly cited topics within each department. What we found within our talent department was that employees loved their caring and supportive peers and stakeholders who they learned a lot from. They also loved the growth opportunities available with the large scopes of work and visibility to leadership. And finally, they enjoyed the fast-paced culture where we move quick and troubleshoot, which allows for continuous learning. After we turned all this qualitative data into quantitative data, we were able to use it in more analyses and directly relate it to employee engagement and satisfaction at Wayfair. I'll hand it over to Aaron to discuss our next example.
Thank you. So Kat mentioned earlier that one of the things that drives her at work is understanding what makes people happy. But I have a slightly different story than that. I grew up a gigantic sports fan. And when I was young, all I really wanted to know was when somebody was shooting a basketball, are they good? And what is it about them that makes them good? And that applies in every job too, in people analytics and employee engagement. We want to understand what are the things that make an employee good at their job. And that can impact all parts of the business, whether that's talent acquisition, our performance competencies themselves. Are we evaluating people on the things that matter? It can help us improve in career development and also showcase diversity and inclusion. So I decided to look at performance reviews, and we took nearly 4,000 reviews from our corporate office in Boston, comprised of almost 100,000 sentences. And I was able to build a topic model that could say, for our strengths and for an employee's opportunities, these are the skills and behaviors that we're evaluating people on. And with some data manipulation, we were able to say, for every employee, this is what level you are in the company. This is how we rated you over the last 6 months. And these are the things that we said you were good at, and these are the things that you should improve on. And again, with just a simple pivot, we're able to say for every level and for every rating, this is what you can expect the average employee to look like. Now at Wayfair, we wanted to understand what are the key skills and behaviors that differentiate our top performers. What are our model employees look like? So we just created 2 simple columns, one evaluating the difference between our top employees and our average employees, just the raw difference, and then one with a % difference and that frequency that you would see something as a strength or an opportunity. And I just wanted to see what are the things that transcend level. I wanted to see, do any of these skills or behaviors have our largest differences or top quartile differences in 3 or more of the 5 levels that we were looking at? And only 2 things popped out. Stakeholder management / cross-functional communication, and taking ownership of one's work. Now, I wanted to loosen that up again to A, have a better understanding, and B, ensure that a couple months of work was going to be more than just 2 skills and behaviors. And what we found was that of the 11 most important topics or skills or behaviors that we evaluate our employees on, 7 of them relate to one's ability to communicate and build relationships within the business. And for us, an emerging tech company that is incredibly technically focused, having an understanding that not only do you need to code, not only do you need to be able to analyze, but you need to be able to tell a story and build relationships with stakeholders to really drive change within the business, this was incredibly helpful for us. Now, this is not perfect. There are definitely limitations. There are things that you can extend. For example, the topic modeling has a hard time dealing with spelling errors. And as I said earlier, it's based on probabilities and not word meanings. So any word that has multiple meanings has a tough time making that differentiation. And there are ways that you can take this to that next level. You can look at trying to cluster the topics to better understand, are there relationships between them? You can do sentiment analysis to say, given that you were talking about this thing, how good or bad was it? How happy or sad were they? But the most important next step to take is to take action. Because at the end of the day, analysis is just to understand, but we're in the business of driving change. We're in the business of trying to make an employee's life better and drive value for the business. And in order to do that, you actually need to do something. But now that I've acknowledged the limitations, I do want to take a step back and really think about what we just said. We are a team of 2 analysts, and we were able to take 10,000 open text comments about what do you like about your job and what makes you happy, and distill that down into 3 things. And we were able to take 4,000 corporate performance reviews and understand that there are two things that are truly differentiating our top employees from those that are average at Wayfair. And I think that's pretty incredible. And I think this is something that can be applied at every company represented in this room to not only have a better understanding of their employee base, but ultimately drive change. So with that, I want to thank you guys so much for having us today and open it up to any questions that we have.
Hi, thanks for the presentation. I thought it was super cool. So outside of like the technical coding skills, because I think I have most of that, where do you recommend getting more info on this topic modeling LDA thing?
So candidly, I had absolutely no background in text analysis before, maybe 8 or 9 months ago. There are plenty of resources online. If you literally just Google LDA topic modeling Python, there are extensive resources available that will literally walk you through step by step, not way more thorough than what we went through, and make it incredibly easy. It's very doable.
One of the other things I'd recommend too is if you have any data science teams within your organizations, one of the things that we do is have meetups every couple months or once a month where we'll meet with different people in data science. Maybe they're working on something really analytical, and we'll just share our projects, and that's a really good way to soundboard and just get more information on what you're doing, kind of like a sanity check.